In this question we are going to have a look at solving the simultaneous equations here. So we've got one equation 4x plus 3y is equal to 18, another equation x minus 3y is equal to 7. So to solve a simultaneous equation we need to eliminate one of the variables, so either x or y. Well, if we look at x, we've got 4x on the top here and then x on its own and 1x here on the bottom. That doesn't really help us because we'd have to manipulate one of these equations so that x was the same value. But if we look at y, we've got plus 3y and then minus 3y here. So we could add these equations together. Why does that work? Well, effectively we've got plus 3y and we're going to add to that minus 3y. This just becomes a negative then, so we're left with plus 3y, so 3y minus 3y, which is equal to 0, which will eliminate that variable for us. So if we do that, add the equation, so 4x plus x is 5x, as we've just said, plus 3y plus negative 3y will leave us with 0, and then we've got 18 plus 7 at the end, which is equal to 25. Then divide both sides of the equation by 5, that will leave us with x is equal to 5. All we need to do then is substitute x back into one of these equations. It doesn't matter which, I'll do the top one just to show you that it can be done with something that looks slightly more complicated. So we're going to substitute x is equal to 5 in, so that will leave us with 4 times 5 plus 3y is equal to 18. That will leave us with 20 plus 3y, which is equal to 18. Take 20 from both sides, that will leave us with 18 minus 20 on the right, and then 3y here. 18 minus 20 is negative 2, and then we've got 3y here. Divide both sides by 3, that leaves us with y is equal to negative 2/3. Now, really big advocate with these questions to check that it actually works. So we just use that top equation, so let's substitute everything into this bottom equation and check that it actually does work. So if we do that, we've got 5 minus 3 multiplied by 2/3, which is equal to 7. Well, if we look at this bracket, we've got 5, so these 3's actually here will cancel, which will leave us with effectively minus 1 times negative 2, which is plus 2, and that is indeed equal to 7. We could also substitute into the top one just to check, so that will leave us with 4 multiplied by 5 plus 3 multiplied by negative 2/3. That should be equal to 18. Well, that leaves us with 20, as we've already calculated, and then plus 3 multiplied by minus 2/3. Again, these 3's will cancel, and that will just leave us with this plus here, minus 2, which is equal to 18. And as we discussed at the top, a plus and a minus just becomes minus, so that's 20 minus 2, which is equal to 18. So we're quite happy, looking at both of the equations, that these values are correct. So x is equal to 5 and y is equal to negative 2/3. You will notice that we now have different amounts of x and y, meaning that we're going to need to manipulate these equations slightly. So I've got 4x plus 3y is equal to 14 here, 5x plus 7y is equal to 11 on the bottom here. Well, if I multiply this top equation by 5 and this bottom equation by 4, that will get me 20x eventually and 20x on the bottom, so we'll have the same amount of x. So what we need to remember is it's this equation, or the whole of this equation, multiplied by 5. So that's 20x plus 15y, which is equal to 5 multiplied by 14, which is equal to 70. Bottom equation, 5x multiplied by 4 is 20x. We've got 7y multiplied by 4, which is equal to 28y. And then we've got 11 multiplied by 4, which is 44. Now we're going to take the top equation and subtract the bottom equation. So it's 20x minus 20x, which is 0x, so we won't write it. 15y, take away 28y, well, that's going to leave me with negative 13y. And then we've got 70 minus 44, and that's equal to 26. All we need to do now is divide both sides of the equation by negative 13, and that will leave me with negative 2 here. All I'm then going to do is substitute that into one of the equations. We'll use the top one, so that's 4x plus 3, and then y is now negative 2, so write that like that, is equal to 14. 3 times negative 2 is negative 6, so that's 4x minus 6, which is equal to 14. Add 6 to both sides, which is going to leave me with 14 plus 6 here, which is 20, which is equal to 4x. Divide both sides by 4, that's 20 divided by 4, which is 5. So x is equal to 5. All we're then going to do is substitute both x and y into that bottom equation, really just to check that it does work. So that's 5 multiplied by x, which is 5, plus 7 multiplied by y, which is negative 2. That should be equal to 11. Let's just check that. So we've got 25. Negative 2 multiplied by 7 is minus 14. And I'm quite happy that that is indeed 11. Question for this video. I'd encourage you to pause it, have a go, and then you can watch the work solution, see if you've got it right or see where you've kind of gone wrong along the way. So, slightly different, because we now don't have the x's and the y's lined up. We've got 4x on the top, 2y on the bottom, 8y on the top, negative 5x on the bottom. So all I'm going to do is take this first equation, leave it as it is, which is equal to negative 4, and then I'm going to rewrite this equation as minus 5x plus 2y, which is equal to 23. Remember, if there's no sign in front of this, we just infer that it is positive, so this equation I've just written is exactly the same as the second equation here. That now lines up the x's and the y's, and now we just need to get the same amount of x or y so we can eliminate and then crack on as we have. We can be a bit cute in this question though. We don't need to multiply both equations, we can just do one. The reason for that is that 8 is a multiple of 2. So if I times this bottom equation by 4, that's going to leave me with negative 5x multiplied by 4, which is negative 20x. 4 multiplied by 2y, which is going to leave me with plus 8y, and then 23 multiplied by 4, which is equal to 92. And then I'm just going to rewrite that first equation on top here, so that's 4x plus 8y, which is equal to negative 4. I'm now going to do top equation subtract the second equation, which will get rid of y. So we've got 4x minus negative 20x. Remember, double negative becomes a plus, so we've effectively got 4x plus 20x, which is 24x. 8y take 8y, 0y, so I'll leave that as is. And then negative 4 minus 92, well, that's going to leave me with negative 96 there. All I need to do then is divide both sides of the equation by 24, which is going to leave me with negative 4 there. I now substitute that back in, so I'll use the top equation, so 4 multiplied by negative 4 plus 8y, which is equal to negative 4. Well, that's negative 16 plus 8y, which is equal to negative 4. I'm going to add 16 to both sides of the equation, so that's going to leave me with negative 4 plus 16, and that is equal to 12 on here, leave me with 8y on this side. Divide both sides by 8, that is equal to y, which is equal to 12 over 8. You can cancel that fraction down, which will become 3 over 2. All I've done there is divide the top by 4 and the bottom by 4. Okay, I'll substitute all of that back into that second equation. So that's going to be 2 multiplied by y, well, we've said that y is 3 over 2. And then minus 5 multiplied by x, which is negative 4, which is equal to 23, or should be equal to 23. Remember, these twos can cancel here, leaving me with 3. And then we've got minus 5 multiplied by negative 4, which is going to be positive 20, which is equal to 23, or should be equal to 23. And indeed, it is. So there are solutions. X is equal to negative 4, and y is equal to 3 over 2.